Okay, so now we're going to prove a very useful theorem, the triangle sum theorem. And the triangle sum theorem states the sum of the interior angles of a triangle is 180. So, for our specific diagram here, if ABC, right, if this polygon is a triangle, then the measure of BAC, so this guy, plus the measure of ABC, this guy, plus the measure of BCA, plus this guy, is equal to 180. Okay, so what we're going to do first is we're going to, of course, start our proof, right? And we're going to consider triangle ABC and draw a line DE uh, parallel to AC. Okay, so we're using the parallel postulate. We can always, whenever there's a parallel line and a point away from the parallel line, there exists exactly one line that goes through the point that is parallel to the other line. Okay, so that is what we are doing here in this instance. Okay, so yeah, I'll just leave it like that. So I can do this right here. This could be line DE, right? And I drew it in the sense where it's going to be parallel to AC, right? Okay, so we know that this angle plus this angle plus this angle is going to be 180 because it creates half a circle, right? It's that linear pair, right? So I know that this angle plus this angle plus this angle is 180. So I'll write that down. So by linear pair, right? I know that, what is that? dBA, right? dBA. So the measure of dBA plus, let's see, the measure of ABC, right? Plus the measure of angle EBC is equal to 180, right? So now the thing why I drew this line parallel to this line is because AB acts as a transversal between DE and AC, right? So if AB is a transversal, that means these two angles are congruent. So that's by AIA, or alternate interior angle theorem, right? We know by the alternate interior angle theorem that this angle is congruent to this angle. That's hit by this, that's cut by this transversal, where these two parallel lines are cut by this transversal. So I know that by AIA, I know that, let's see, dBA, so the measure of angle dBA is equal to the measure of angle, let's see, BAC, right? All right, and we're going to use the alternate interior angle theorem again. We know that this angle here is going to be congruent to this one, right? Because these are alternate interior angles uh, that are cut by this transversal with these two parallel lines, right? So we know that EBC, so let's go ahead. So we know the measure of angle EBC is equal to the measure of angle BCA, right? So now we have exactly what we need, right? Because if this angle is the same as this angle, and this angle is same as this angle, right? Then this angle plus this angle plus this angle is 180 because this angle plus this angle plus this angle is 180, right? So all we have to do is use substitution here. So We have, let's see, bilinear pair, we know that DBA plus ABC plus EBC is 180. So instead of writing DBA, I write BAC. So this implies that the measure of angle BAC plus the measure of angle ABC, right? Plus, and instead of writing EBC, right? EBC right here, I can write BCA, which is exactly what I want, right? Right? So I get exactly what I want using this nice little argument using the parallel postulate. That's it.